Countdown.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hello, Assalamualaikum, salam sejahtera dan selamat petang. Hai para guru, ibu bapa, para pelajar yang saya kasihi sekalian. So selamat datang ke Tuisyen Akademi YouTuber usaha sama dengan e-didik Malaysia dan Kelab Guru Malaysia. Bermula percuma, selamanya percuma. So untuk mendapatkan keberkatan pada kelas kita ini, okey, mari kita berdoa dan bagi Muslim kita baca Ummul Kitab Al-Fatihah. Baik, apa khabar semua? So saya harap ya semua berada dalam keadaan yang sihat, okey, dan bersemangat ya untuk meneruskan kelas kita pada petang ini. Okey, baik. Saya adalah Cikgu Wahidah binti Zakaria selaku moderator dalam kelas pada petang ini. Jadi hari ini kita ada kelas apa? Kelas tuition bagi subjek chemistry pra-university. Okay, dan kelas ini merupakan kelas siri yang keempat bagi channel Cikgu Shahnon. Baik, saya bersama saya juga ya. Pada petang ini adalah Cikgu In dan juga Cikgu Tang. Okey, kita perkenalkan diri dulu. Nama penuh Cikgu Shahnon iaitu Mat Shahnon, okey, AYU daripada Kolej Matrikulasi Pulau Pinang. Okey, dan subjek yang akan diajar oleh Cikgu Shahnon pada petang ini, okey, bertajuk Haloalkanes untuk mekanisme Sn1 dan Sn2. Okey, dan kelas ini akan berlangsung lebih kurang 1 jam. Okey, 1 jam. Okey, so kita ada Cikgu Lim Yit Im, okey, daripada Kolej Tingkatan 6 Tapah, okey, sebagai control host. Okey, dan juga Cikgu Tang Ingin daripada Kolej Matrikulasi Selangor sebagai pemerhati kelas bersama kita di konti pada petang ini. Okey, so sebelum kita teruskan kelas kita pada petang ini, ingin saya ingatkan semua pelajar dan penonton yang ingin menghantar komen dekat chatbox di sebelah, okey, menggunakan bahasa yang sopan dan gambar profil yang bersesuaian untuk tuntunan umum. Okey, jadi saya percaya semuanya merupakan pelajar yang bagus ya, yang berdisiplin. Okey, jadi sila fokus pada pelajaran selama 1 jam ini yang akan disampaikan oleh Cikgu Shahnon. Okey, dengan itu, okey, tanpa membuang masa lagi, saya serahkan kelas kita kepada Cikgu Shahnon. Dipersilakan.
Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Welcome to my class. Okay. So this is my poster. As you can see here, our class every Sunday 3:30 p.m. Okay. Okay. This is my profile. My name is Shahnon bin Awi from Kolej Matrikulasi Pulau Pinang. My teaching experience 20 years actually. I'm start teaching in year 2000. Almost 21 years, and my YouTube channel is Shahnon channel. Okay, this is Kimia Prayu. Kimia Prayu, we have a collection of video PDPC for STPM and matriculation. Okay, we have a teacher Yi, teacher Lau, teacher Tang, me here, and Cikgu Mawar and teacher Kong. And this is our teammate, mathematics, okay. Also has a video collection, STPM and matriculation, led by teacher In, our host controller today, teacher Eileen and teacher Zana. Teacher Zana actually last week her retirement become YB lah, become YB yang bersara, correct? And this is biology teammates led by Cikgu Faizah, and we have Cikgu Fatia, Cikgu Naini, and Cikgu Wawa, our moderator today. And this one is per accountant and economy, per AYU, led by Madam Fizi, and the others is Cikgu Yati, Cikgu Lee, and Cikgu Yi. And the last one is from physics. Okay, from physics. Actually, physics still not has live streaming yet, but I think that soon we will have a physics. Okay, physics. That and their collection video. Yes, they have the collection video from STPM and Para University. Okay, STPM and matriculation. Okay, and this is our portal, Academy YouTuber Malaysia, Pusat Tuisyen AYU, and you can find more information from here. You just have to surf www.academyyoutuber.com. Okay. All right. Now let's go to our business, which is Sn1 and Sn2 mechanism. Our objective, number one, is explain nucleophilic substitution reaction of haloalkane with H2O, NaOH, ammonia, and potassium cyanate. And then explain Sn1 mechanism and compare reactivity of primary, secondary, and tertiary haloalkanes. And the third one, explain Sn2 mechanism and compare reactivity of the primary, secondary, and tertiary haloalkanes towards Sn2 mechanism. Okay. Okay, before that, we look at the chemical reaction of haloalkane, okay, due to the polar carbon and halogen bond. Okay, we know that halogen, this one is halogen X. Halogen is more electronegative than carbon. Therefore, halogen become partially negative and carbon become partially positive. So the nucleophile, here is nucleophile. Nucleophile will attack the carbon here because carbon here is partially positive, and we call this carbon is alpha carbon. Okay, alpha carbon can be attacked by a nucleophile, and halogen here, this one is halogen X, can leave as the stable halide ion. Okay, and in haloalkane, actually it has two type of reaction. Number one is nucleophilic substitution. Okay, as what I mentioned before. The nucleophile is OH minus, H2O, ammonia, Cn minus, and so on. What happen is X here, halogen, will be replaced with nucleophile. Okay, as we can see here. Now here we have a nucleophile here. The second one is elimination reaction. All right. In this case, X and H will be eliminated, and we will have alkene or unsaturated hydrocarbon. Okay, but today we will cover this one, nucleophilic substitution reaction. And for nucleophilic substitution reaction, we will cover only these three reagent. Number one is sodium hydroxide, aqueous. Okay, what happened is bromine will be replaced by OH, hydroxyl group. The second one is formation of amine, reaction of haloalkane with ammonia. Okay, Br will be replaced with NH2 here in the presence of ethanol and heat. Okay, bromine will be replaced with NH2 here and it's become amine. We call it amine, this compound. And the third one is formation of nitrile reaction with KCN, haloalkane here, react with KCN, or KCN here, and what happens is the bromine here will be replaced with CN in the presence of ethanol. ETOH is ethanol, H2O, and reflux. Okay, this is nucleophilic substitution. And for nucleophilic substitution, as I mentioned before, it has two types of nucleophilic substitution. Number one is Sn1, and number two is Sn2. What is Sn1? Sn1 is unimolecular nucleophilic substitution, and Sn2 is bimolecular nucleophilic substitution. In other words, we can Sn1, we read this Sn1 from right to left. One is unimolecular and is nucleophilic, S is substitution. For this one, the number of 2 here is a bimolecular, N is nucleophilic, and S is substitution. Okay. Okay, and we go to the Sn1 first. S1 is unimolecular nucleophilic substitution, right? Unimolecular substitution reaction. Okay. And unimolecular, why we call it unimolecular? Because the rate determining step involve one species only, which is haloalkane. Rx is haloalkane or agar halide. Okay, haloalkane, agar halide, the same one. Thus, the rate of reaction only depends on concentration of haloalkane. Okay, only on haloalkane. So we can write the rate law or the rate equation. Rate equal to K concentration of Rx. If you look at this rate law, we know that this is first order reaction because the power of Rx is 1. Okay? The power of Rx is 1. So order of this reaction is 1. So this is fit with Sn1 here. Okay, 1 here refer to the only depends on concentration of haloalkane, and the order of reaction is 1. Okay, Sn1 here, 1, number 1 here, refer to the haloalkanes, and the order of reaction with respect to haloalkane is 1. Okay, and this reaction actually, the tertiary of haloalkane is the fastest. Okay, the reaction of the tertiary haloalkane is the fastest, and the formation of carbocation intermediate, and because of the formation of carbocation, sometimes we can see the rearrangement. Okay, rearrangement from less stable of carbocation to more stable carbocation, and it's involve weak nucleophile. How do we know the weak nucleophile? Weak nucleophile. The weak nucleophile is what we call it, the molecule that no negative sign. No negative sign. For example, here H2O. H2O only it has a lone pair here on oxygen. Alcohol also only lone pair, and ammonia also only lone pair. So the species that do not has a negative charge is weak nucleophile. Okay, so in this case, we need a tertiary haloalkane and weak nucleophile. Therefore, it will follow the Sn1 mechanism. Okay, the mechanism involves 2 steps. Okay, for Sn1, the mechanism involves 2 steps. Number 1 is, we call it formation of carbocation, and the number 2 is nucleophilic attack. All right, this is Sn1 mechanism. Now we look at the, let me see if I have any question. Okay, still no. Okay, good. Now, example for unimolecular nucleophilic substitution Sn1. Okay, look at here. We have a tertiary haloalkane, right? This is The name for this haloalkane is, according to IUPAC, is 2-bromo 2-methyl propane. All right, 2-bromo 2-methyl propane. This is tertiary haloalkane because carbon that bear bromine here attached to other 3 carbon. Okay, 1, 2, 3. So this is tertiary haloalkane. As I mentioned before, the tertiary haloalkane are prone to follow Sn1 mechanism. Okay, this is sodium hydroxide aqueous lah. What happen is bromine here will be replaced by OH. Okay, that's what we call substitution. Okay, nucleophilic substitution, because the nucleophile here is, okay, we will see after this. All right, here is the mechanism. Okay, step number one is formation of carbocation. This is tertiary haloalkane here. All right, and then because this bond carbon and bromine here, bromine is more the bond here is polar because bromine is more electronegative than carbon, and when this bond will break, okay, this bond will break, and the 2 electron here will be given to the bromine. Okay, given to the bromine. This is heterolytic cleavage. Okay, this is heterolytic cleavage, and this is the rate determining step, and this process is slow, and what happen is formation of carbocation and Br minus. Okay, we have this. This is the first step. Okay, very easy. We just write the curve double-headed arrow. Okay, we call it curve. Okay, because this is curve, and the head of the arrow is a double. Okay, curve double-headed arrow. Double-headed arrow means heterolytic cleavage. Okay, and then the second step. Okay, we look at the second step. The second step is nucleophile attack on the carbocation. Okay, this is the carbocation from the first step, and because this is Sn1, we will choose weak nucleophile. In this case, okay, we look at first at this equation. In this equation, we have sodium hydroxide aqueous. That means in this equation, we have 2 types of nucleophile. Number 1 is OH minus. Number 2 is H2O. Aqueous here means it has H2O. So, because this is Sn1, we will choose H2O as a nucleophile. Okay, we not choose OH minus. Okay, go back. All right. Okay, H2O will attack the carbocation here, C plus, and what happened? Now it's become protonated alcohol. Why the name is protonated alcohol? If you look at this structure, this is actually is alcohol, okay, OH, but this alcohol has extra proton here, H is proton. That's why we call it protonated alcohol. Alcohol that has extra proton. Okay, OH, 2H, and plus. Okay, H plus. Okay, we call it protonated alcohol. Okay, and then we have another H2O. Another H2O here will attack H. Okay, it will attack H, and the bond between oxygen and hydrogen here will break heterolytically. Okay, because this is heterolytic cleavage, give to the O here, and now it's become alcohol, and OH2 here become H3O plus, which is acid. Okay, which is acid. Okay, the protonated alcohol will loss of H plus. Okay, from the protonated alcohol, because this is protonated alcohol, and it's become alcohol. So this is 2 steps. 2 step of mechanism of Sn1 mechanism. Okay, very easy. All right. Okay, now we look at we call it animation lah. Okay, we look at this animation. Simple animation, just using PowerPoint. Okay, the formation of carbocation. How this the formation of carbocation. Okay, can you see? there is a 2 electron given to the Br. It's become carbocation, okay? Just easy like that. And then this is the second step, nucleophilic attack. Now we have H2O or H2O now attack the carbocation. It's become protonated alcohol. All right. And then we have another H2O come to, yeah. Okay. All right. Now it's become alcohol. And this is H3O plus. This is a very simple, what we call it, very simple animation. Maybe the student out there can make a good animation from this one. Okay, this is just very simple, just a simple mechanism to understand how the mechanism of Sn1 mechanism. Okay. And the reactivity toward Sn1, the rate of reaction is dependent on the stability of carbocation form. All right, that's why in this case, here we have a tertiary carbocation. Tertiary carbocations more reactive toward Sn1 mechanism compared to secondary. This is secondary haloalkane. This is primary haloalkane. This is a methyl haloalkane. Okay, so the reactivity toward Sn1, we will choose tertiary actually. Okay, because for methyls to form carbocation of methyl carbocation not stable. The tertiary, only the tertiary carbocation is stable carbocation. That's why for Sn1 mechanism, it's prefer tertiary carbocation. Okay. And then, okay, the rate of reaction depend on haloalkane, as we know that this is the rate of Sn1 rate equal to K concentration of haloalkane. And then involve two step, as I mentioned before, formation of carbocation. This is slow step, rate determining step. And the second step, a nucleophile attack on the carbocation to form protonated alcohol and then to form alcohol for sodium hydroxide aqueous. And for your information, we can change if we change to let's say ammonia, for example. Okay, it also will involve two step for tertiary haloalkane. And the first step is formation of carbocation, and the second step also nucleophile attack. That means ammonia will attack carbocation and form amine. Okay. All right. So any question? Okay, no. Good. Now we look at this question. Yeah. The rate equation for the reaction of CH3 to CCl, CH2, CH3. Okay, this is the structure of haloalkane with sodium hydroxide aqueous. Okay, with sodium hydroxide aqueous is given below. Discuss the mechanism of the reaction. Okay, in this case, this question, we are given rate law or rate equation of the reaction of this haloalkane. Okay, the rate is rate equal to K, and then this is haloalkane CH3 to CCl, CH2, CH3. This is haloalkane. Okay, to discuss the mechanism. Okay, to discuss the mechanism, first of all, we have to look at, as I mentioned before, we have to look at the haloalkane. Okay, the type of haloalkane here is, as we can see, the chlorine here. Okay, let me have a pen here, digital pen. It's my pen. Okay. Okay, to look at this here, it's easy for us if we redraw. Okay, let me choose highlighter. We redraw this haloalkane, so easy for us to determine the class of haloalkane. Okay, CH3, we have two CH3 here, attached to this carbon, and this carbon also has a chlorine and CH2 and CH2. Okay, this is the structure of haloalkane. And if you look at this carbon, this is alpha carbon. This carbon attached to 3 other carbon, 1, 2, 3. Therefore, this is tertiary haloalkane. So this is clear that this is tertiary haloalkane. So the mechanism will follow the Sn1. All right. This is number one. The second one is, because we have to discuss the mechanism, right? We look at the rate of the reaction. The rate of reaction here, only we have a haloalkane here, no nucleophile. That's mean only haloalkane, and the order of reaction is 1. Okay, so Sn1, as I mentioned before, refer to the order of reaction and refer to the only one species, which is haloalkane. All right. So I want to erase all these things. So from here, it's clear that the mechanism of the reaction is Sn1. Okay, the mechanism of the reaction is Sn1 because the order of reaction is first order, and the class of haloalkane is tertiary. All right, this is how we want to discuss the mechanism, and the rest is, well, we have to write the mechanism lah. But I don't want to write the mechanism here. You have to write on your own the mechanism of what's the name for this one? Let me see the name. Okay, the name of this haloalkane is 1, 2, 3, 4. 2 chloro, 2 methyl, butane, right? 2 chloro, 2 methyl, butane. Okay, you have to write the mechanism, follow the Sn1 mechanism. 2 step. Number 1 is formation of carbocation. The second one is nucleophile attack, and the nucleophile is this one, aqueous. Aqueous mean H2O. Okay, you have to use H2O to show the mechanism, not OH minus, because this is Sn1 mechanism. Okay, any question before we go to
Setakat ni Cikgu Shahnon tak ada lagi question.
Okay, good.
Cikgu Shahnon, question satu dah habis ke ni?
Habis dah.
Alright, so sebelum Cikgu sambung seterusnya, kita nak break sekejap ya.
Okay, break. Alright.
Stay tune.
Misi pencarian ikon e-didik junior kini bermula. Siapakah yang layak dinobatkan sebagai ikon e-didik junior bagi tahun ini? Jom sertai misi pencarian ini. Syarat-syarat penyertaan: anda mestilah menyertai Pusat Tuisyen PERCUMA AYU dan juga mestilah mendaftar untuk mendapatkan ID AYU masing-masing. Juga perlu menjawab soalan yang akan diberikan pada setiap minggu. Dan akhir sekali, perlu menjalani ujian akhir bagi penentuan ikon e-didik junior. Jadi, apa tunggu lagi? Adakah anda ikon yang kami cari? Adakah anda telah bersedia? Peluang di tangan anda. Untuk maklumat lanjut, layari www.academyoutuber.com.
Okey, baik, kita kembali bersama Cikgu Shahnon dengan topik haloalkane bagi mekanisme Sn1 and Sn2. Okey, dipersilakan Cikgu.
Okay, welcome back. Okay, now we look at the Sn2 mechanism. Okay, Sn2 is bimolecular nucleophilic substitution. And then the rate determining step involves 2 species. Okay, this one is 2 species, which is haloalkane and nucleophile. Okay, nucleophile. So the rate of reaction is rate equal to K and concentration of haloalkane and concentration of nucleophile. So the order of reaction is second order, right? Because, okay, look at this. Order of reaction with respect to Rx is 1. Okay, let me show here. And order of reaction with respect to nucleophile is 1. 1 and 1. So total, we call it order of reaction is 1 plus 1 is second. Okay, 1 and 1 is 2. So this is second order reaction. All right. So the Sn2 here, okay, actually refer to the number 1 is 2 species, Rx and nucleophile. And 2 here also refer to the second order of reaction. Reaction is meta halide is the fastest. So of course Sn2 must be bertentangan, okay, must be bertentangan from Sn1. Okay, the fastest is meta halide, not the tertiary haloalkane, and need strong nucleophile. In this case, we need strong nucleophile. OH minus, CH3O minus, all are anion. Okay, all are anion. And then no carbocation ion intermediate, only activated complex will form, and mechanism involve only one step. Okay, one step. Here is 2, but now the mechanism is one step. Okay, for Sn1, 1, but the mechanism is 2. Okay, don't get confused. Okay, the bond breaking and bond forming occur simultaneously. Okay, example for the reaction is, okay, this is a primary haloalkane. Okay, this one is primary haloalkane because this carbon attached to one carbon, right? This is primary haloalkane. And then sodium hydroxide aqueous, the product is also alcohol and HCl. Okay, the product is the same, but the mechanism is different. Okay, now we look at the mechanism. In case of Sn2 mechanism, we have to draw the structure in 3D. Okay, in 3D. In this case, the structure in what we call line, wedge, and dash projection. Okay, so this is carbon, the alpha carbon, okay, attached to chlorine and CH3, and this is the wedge, means it's project out, and here we have dot line. Okay, dot line is ke dalam lah, ke dalam. Okay, this is 3D. In case of Sn2 mechanism, we have to draw the structure in 3D like this. Okay, C, Cl, CH3, NH, NH like this. And this is nucleophile. The nucleophile must be strong. In this case, is OH minus. Okay, and the nucleophile will attack the alpha carbon from behind. Okay, from behind, cannot attack from here because the chlorine, actually the the size of chlorine quite big, and it will shield the carbon. Okay, that's why nucleophile will attack from behind. Okay, okay, we use still we have to use the curve double-headed arrow. Okay, curve double-headed arrow attack the alpha carbon here because the carbon here is partially positive, chlorine here is partially negative, and then at the same time, the bond between carbon and chlorine will break heterolytically. Okay, the 2 electron will be given to the chlorine. All right, and what happened? This is what happened. OH here. Now we will write like this: the dot line and dot line. The OH and C here means bond. This one is bond. This one is bond breaking for carbon and chlorine. The bond breaking, and for OH and carbon, bond forming. Okay, the bond forming. Remember that when we write the the bond here, make sure that carbon and oxygen, all right, not carbon and hydrogen, because the bond forming here between oxygen and carbon. Okay, right, like this. OH. Okay, now we have a dot 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 dot, means bond forming between oxygen and carbon. And here we have carbon and chlorine, dot 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 dot, means bond breaking. Okay, okay. And this one we call it transition state. This is transition state. Okay, the species here we call it activated complex. Okay, this is activated complex. Complex, very complex. All right, because as we can see here, we have 5 bond. Okay, and then okay, when the bond forming is completed, now we have COH, which is alcohol, and the chlorine here leave the carbon here as an anion, right? Okay, in this step, 2 species are involved, as I mentioned before, the haloalkane and also the nucleophile. Okay, thus the term bimolecular come out. And then the backside attack by nucleophile causes, this is backside attack, and causes an inversion of configuration. Oh, what happened? Okay. 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 Backside attack causes an inversion of configuration. Okay. As we can see here, the conversion is like this, and when OH bond form here, and the conversion like this. Okay, if I can redraw something like this, and then see. Okay, this is what we call inversion of configuration. This is the uh, configuration before nucleophile attack. Okay, 1, 2, 3, and 1 here. Here is for halogen, and when nucleophile bond with carbon here, now the configuration become like this, 1, 2, 3 here. So this is the things that we have to make sure when we write the mechanism of Sn2. Okay?
Cikgu
Ya,
Shahnon, boleh
ya.
jawab sekarang tak? Ada soalan
Boleh.
daripada student, nama dia Basantra Muniandi. So
Okay,
he
alright.
asked how to know it is a strong nucleophile.
Okay, good
Untuk saya
question.
school.
Okay. How do we know? Okay, we look at this one. Nucleophile actually, this is the nucleophile is, we have a negative sign here. Okay, this is strong nucleophile. Okay, we have a OH minus, Cn minus, OCH3O minus. All the anions or anion are strong nucleophile. All right. For weak nucleophile, for example, H2O only lone pair in on oxygen. Ammonia, NH3 only lone pair. This is weak nucleophile. All right. Okay, that's my answer. How do we know the nucleophile is strong or weak nucleophile? Okay. Any other question?
Not yet. So
Not yet. Right.
belum lagi muncul.
So okay,
Kalau
I
saya
can
tanya
continue.
boleh tak? Kalau sempat
Okay.
saya tanya boleh tak?
Okay.
Cikgu Shahnon, backside attack tu apa?
Backside from behind dia belakang. Okay. I can show this one. This one. Okay, this one. Reactivity of haloalkane Sn2 reaction is determined by the steric effect. Okay, this one I will show you what is backside attack. Okay, reaction is determined by the steric effect, which is size of spatial arrangement of alkyl group attached to near to the reaction site of the molecule. For example, if you look at this, okay, this is tertiary haloalkane. Tertiary haloalkane, it has 2 alkyl group, which is this is what we call bigger steric effect lah. Okay, for the this is methyl because it is less steric effect, only hydrogen. So look at here, steric hindrance of Sn2 mechanism. Okay, as we can see here, okay, this is carbon, bromine. Okay, where is the bromine? Bromine is the brown one. This is the bromine, which is the carbon, the alpha carbon is the black one here. Okay, the black one, and CH3 is this one. This is carbon, and we have 1, 2, 3. This is hydrogen, and the other hydrogen here is here, and here. So if the nucleophile want to attack from front of the alpha carbon, cannot, because the bromine now shield the carbon, cannot. So the nucleophile will attack from behind. From behind, because we can see the carbon here. Okay, the black one here, carbon. So it can attack carbon, and then the bromine will leave as a nucleophile, also nucleophile lah. So the nucleophile attack is easy for ethyl bromide. This one we call it ethyl bromide, and the ethyl bromide is a primary haloalkane, because we can see the carbon here. Okay, the nucleophile can attack carbon. All right. For the second one here, this is a secondary haloalkane, isopropyl bromide. Okay, we have a CH3 and also CH3 here. This is CH3, and here also the CH3, and this is hydrogen. Now we can see that the room for nucleophile attacks now is very little. Okay, not easy for nucleophile to attack, because the carbon now is covered by the CH3 here. This is what we call steric hindrance. Okay, but it still can attack, because we can see the carbon here. Okay, still possible for nucleophile to attack. But for the tertiary haloalkane, now this is tertiary haloalkane. CH3, CH3, and CH3. This is CH3, CH3, CH3. Nucleophile cannot attack, because the nucleophile, there is we can see the carbon now. The carbon is covered by CH3. We call it alkyl, alkyl group. The alkyl group now cover, and bromine also cover, so no room for nucleophile to attack from behind. So impossible for nucleophile to attack. Right? This is what we call steric hindrance. That's why for Sn2 mechanism, prefer methyl halide or primary haloalkane. Okay. Okay, now we look at the differences between Sn1 and Sn2. The Sn1 carbocation Sn intermediate. Okay, the two-step mechanism, and the rate of reaction is K, and concentration of haloalkane, and this is first order of reaction. Reactivity to Sn1 is tertiary haloalkane is the fastest, followed by the secondary, primary, and methyl halide. And the rearrangements are common. Why? Because formation of carbocation. As what we have learned before, the carbocation, if formation of carbocation, for example, primary carbocation, if the primary carbocation can rearrangement to form more stable carbocation, for example, tertiary carbocation, yes, the carbocation will rearrange. And then for Sn2, no carbocation form, only transition state, only one step mechanism. The rate of reaction is rate equal to K, haloalkane and nucleophile. This is second order reaction. And reactivity toward Sn2, methyl halide. Methyl halide is the fastest towards Sn2. Okay, and the no rearrangement. That's mean for Sn2 mechanism, we only can get one product. Okay, only one product can form. But for Sn2, maybe we can get 1 or maybe 2 because of the arrangement of carbocation ion. Okay. Okay, we look at this second question. Show the conversion of 1 chloropropane to 1 propanol. The reaction rate is affected by both 1 chlorobutane and nucleophile. A, write the rate equation, state the order of reaction. B, state the type of reaction, and C, write the mechanism for the above reaction. If you look at this question, the reaction rate is affected by both. So this is the keyword. Both 1 chlorobutane and nucleophile. That means this is Sn2 mechanism. So the rate is, write the rate equation. Okay, should be haloalkane CH3 CH2 CH2Cl. This is 1 chloropropane, and the nucleophile is we take the strong nucleophile because this is Sn2 mechanism, OH minus. All right. And then state the mechanism. Of course, this is Sn2 mechanism, bimolecular nucleophilic substitution, and write the mechanism. Okay, so I think I have to write this one. Okay, this is C and then Cl. Okay, we have to write like this. Okay. H here, and here we have 1, 2, 2. So this one CH2, CH3, something like this. And then OH minus. OH minus will attack from behind. All right, yeah. Any question?
Okay. Not yet. Tak ada lagi
Not yet.
question.
All right. Okay. So something like this. Huh?
Macam mana nak ingat nak buat macam tadi ada equation, tadi ada macam molecular formula yang panjang tu kan? Macam mana dia orang nak gunakan structural formula ni?
Oh, from here to here. Yang ni orang kimia tau. Okay. Okay, no problem. Okay, so remember that this is we have to write the reverse configuration. Okay, now it's become CH2, CH3, and then H. Okay, my pen is not very good. Sn minus, something like this. Okay, this is Sn2 mechanism, very easy, one step. This is slow, this is fast, so on. Okay, remember that this is must be in 3D, wedge and dash, line and wedge dash projection, and then wedge minus attack from behind. Okay, don't forget this is activated complex. Okay, activated complex, dotted line, and then when it's become alcohol, okay, reverse configuration from here to here. Okay. Question 3. Hydrolysis of 1 bromo to 2-dimethylpropane produce 2-methyl-2-butanol as a major product instead of 2,2-dimethylpropanol. Explain. If you look at this question, hydrolysis of 1 bromo to 2-dimethylpropane produce two species of haloalkane. That means we have 2 products. If we have 2 products, that means this must be Sn1. Okay, must be Sn1 because of rearrangement. Okay, this is what we have to understand before we answer this question. Okay, and for chemistry student, of course, they have to know how to write this one. 1 bromo to 2-dimethylpropane. 1 bromo to 2-dimethylpropane is primary haloalkane. This is primary haloalkane. Okay, I just show the formula. Okay, the formula of 1 bromo to 2-dimethyl because I think our time is I'm quite running out of time. Okay, this is primary haloalkane. How many minutes that I have?
Okay, 10 minutes. 10
10 minutes.
minutes.
Okay. Okay, good. Okay, this is primary haloalkane. As we have we learned before, for primary haloalkane, usually we will think that this is Sn2 mechanism, right? But in this case, even though this is a primary haloalkane, the product is two. The product is two, major and minor. That's mean there must be a rearrangement. For rearrangement, the formation of carbocation must be happen, and for carbocation, the mechanism must be Sn1, not Sn2. Okay, so why the primary carbocation primary carbocation, why primary haloalkane will follow Sn1? This is because of the bulky, as we can see, this is what we call a bulky group here. Okay, bulky group here, because of the steric hindrance, not easy for nucleophile to attack alpha carbon from behind. Therefore, this haloalkane want to form alcohol, so it will choose other than Sn2 mechanism, which is Sn1. Okay. Okay, this is the reaction. Okay, and this is the answer lah. 1-bromo to 2-dimethylpropane is a primary haloalkane. Okay, primary haloalkane, but does not undergo Sn2 mechanism. Okay, not undergo Sn due to the steric hindrance effect. This is what called steric hindrance. Steric hindrance effect because of this one, CH3. This is a bulky alkyl group. The bulky alkyl group, and which is attached to the alpha carbon. This is alpha carbon. This is alpha carbon. Because of this, not easy for nucleophile to attack alpha carbon from behind, and then this haloalkane will follow Sn1 mechanism, and then it for Sn1 mechanism, we will get primary haloalkane, and then the rearrangement become tertiary. I cannot show from here because the time is quite running out. Okay, but you can refer to reference books, or you can ask question after this. Okay, but I just give the idea that if we know whether this is Sn1 or Sn2, if we have two product, for sure this is Sn1 mechanism, even though the haloalkane is the primary haloalkane, because of steric hindrance. There must be have something that very bulky here lah. If no bulky group, then it will follow the Sn2 mechanism, and we will get only one product. But in this case, the the keyword is two major and minor. Where is the minor? The major product is this one, and this is minor product. Okay, because of this, we know that this is Sn1 mechanism. Okay, all right. Okay, hence it does not undergo Sn2 mechanism. Instead, it's undergo Sn1 mechanism. Okay, all right. And then question number 4. Okay, question number 4 is easy to answer. Okay, you can write the answer on our chat box. The rate of Sn1 reaction is fastest in the hydrolysis of A, 2-chloropropane, B, 1-chloropropane, C, 2-chloro-2-methylpropane, and D, 1-chloro-2,2-dimethylpropane. Okay. Okay, student, answer this question. A, B, or C, or D? Okay.
Okay, you can type here in chat box your answer. Okay, students.
A,
Okay,
B,
saya
C, D.
nampak sini. Lebih kurang 12 orang.
Okay. What is the answer? A, B,
Okay.
C, D. Still no answer?
None answer.
Very easy, yeah. This one is very easy.
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 Dia ada Basantra.
For
Okay, Aina Yasmin, she
yeah,
answered D, donkey.
D donkey. Okay.
Maybe.
Okay. If you look at the Sn1, we try to find the tertiary haloalkane. Which one is the tertiary haloalkane? Okay. Sn1, right? Sn1. Try to find the tertiary haloalkane. Okay. A.
What about
Look at the
what about D? Anis Zahira answered D pula.
D also. Okay. D, one chloro to 2-dimethyl-propane. Okay. For 2-chloropropane, this is actually secondary haloalkane. 1-chloro propane is primary haloalkane. And for D, 1-chloro to 2-dimethyl-propane, this is also primary haloalkane with bulky group. Okay, this is bulky group. Okay, attached to the alpha carbon. And for this one, 2-chloro-2-methylpropane is a tertiary haloalkane. So which one is the best answer for this question number 4?
So yang jawab ni dia tukar D juga.
Dah tukar D juga.
Ha.
Oh, answer is D ya.
Ni soalan
Okay.
paper 1 tu.
Paper 1 tak wujud dah. The answer is C ya. The answer is C.
Yes, the
Because
answer is C. Tak apa.
C
Good try.
Okay, good try. Because C is a tertiary haloalkane. Even though we have a primary haloalkane with a bulky group, we still prefer the tertiary haloalkane, which is fastest in Sn1 mechanism, right? If we don't have a tertiary haloalkane, then we will choose D. Because D is a primary, but has a bulky group that attached to the alpha carbon, right? Okay, go to the question number 5.
Next.
Next question.
Okay.
The following statement are true about Sn1 reaction, except A, easy to occur for primary alkyl halide. B is a first order reaction, occur via the formation of carboxyl ion, and D occur easily with the presence of a good leaving group. Okay.
So soalan ni minta yang salah lah kan? Accept.
Yeah, accept. The following statement
So
are true.
anyone?
Okay, we have 3 minutes left. Okay.
Tak ada cikgu,
Okay,
tak
what?
apa. Tak ada answer
Okay,
lagi.
what is the answer? Tak ada lagi, I can wait. We have 3 minutes.
Okay, try. Okay, dengan malu-malu, tak apa. Salah kita betulkan. Kenapa salah tu?
Okay, which ones? The following statement are true about Sn1, except easy to occur for primary alkyl halide. B, first order reaction. Okay.
Aina choose A.
Choose A, okay, good. Aina choose A.
Okay, anyone else?
And oneself, A, okay, and then Aina Yasmin, A. Only Aina Yasmin,
Tu saja setakat ni.
Only one. Only Aina Yasmin.
Kadang dia orang ni malu cikgu nak bagi jawapan. Takut salah ke
Malu.
kan.
Bukan orang nampak muka pun. Bukan orang nampak muka kan. Tulis pun. Okay. The answer is let's A. Okay. Answer is A. Easy to occur for primary alkyl halide because for Sn1 it's easy to occur for tertiary, right? Tertiary alkyl halide. No. And first order, yes, Sn1 is first order occur via the formation of carboxyl. Yes, Sn1 is and occur easily with the presence of good leaving group. If we have a good leaving group, then easy for the haloalkane to form carboxyl ion. So for today, only this. Okay.
Okey, habis dah cikgu. Okey, tak apa.
Habis
Cikgu
dah.
Shahnon kita bagi sepatah dua
Ya.
kata dulu.
Dah nanti tunjuk ni dulu. Okay, this is my new what lah? Channel art. Okay, this is my new channel art.
Benar.
If you go to my channel, okay, YouTube channel, you will see this one lah. My new channel art. Okay, lawa. Feel free to come to my channel lah. Okay, thank you. This is my what we call it lah. www.youtube.com/Shahnon channel. This is my URL ko dah. URL lah. Okay, you can come here. Can many banyak lagi video-video PDBC kimia yang ada di sini ya. Okay, so itu saja daripada saya untuk kali ini. Jadi sekian dulu lah.
Okey, terima kasih Cikgu Shahnon. Okey, so alhamdulillah selesai kelas kita pada petang ini. Okey, terima kasih banyak sekali lagi Kak Cikgu Shahnon. Okey, jangan lupa ya pelajar-pelajar. Okey, kita akan bersara langsung pada waktu yang sama juga tau next week. Okey, dengan Cikgu Shahnon juga kan? Okey, ya ke cikgu lain pula?
Nantilah kita tengok.
Okey, nanti kita akan buat promotion ya. Okey, so tahniah pelajar yang stay tune dengan kita. Okey, walaupun tak ramai tak apa. Okey, kamu kena ajak lagi rakan-rakan kamu. Okey, pada waktu yang sama ya, pada setiap minggu. Okey, so kita nak persilakan kita punya Cikgu Im, kita punya yang berada di konti bersama kita petang ini untuk memberi sepatah dua kata. Ada?
Hi, wow. Saya pun belajar kimia, Cikgu Shahnon. It is a good explanation for people like we all have been graduate like the past 20, 30 years already. This is a refreshment. It's a good explanation. Congratulations, Cikgu Shahnon. And I hope all the students out there also are able to get, and please share this with your friends. Okay, please share this with your friends, because by learning and keep on learning, you will score better. All right, bye.
Thank you Cikgu Im. Okay, now kita ke Cikgu Tang. Okay, Cikgu Tang boleh on microphone. Sepatah dua kata.
Syabas Cikgu Shahnon, it's a very clear explanations, very good. I think all students, they are very clear now how to differentiate between Sn1 and Sn2 and which class of Haloalkane can undergo Sn1 or Sn2. Very good. Thank you Cikgu Shahnon.
Okay, that's all Teacher Tang. Alright, terima kasih. Okey, daripada Cikgu Awal pula, saya mengharapkan para pelajar ya menggunakan kelas tuition percuma kita ni dengan semaksimum mungkin. Okey, mungkin kamu rasa macam tak cukup masa dan sebagainya. Sebenarnya kita boleh je buat multitask sambil dengar kelas Cikgu Shahnon ni. Okey, sambil-sambil kita makan ke apa ke, buat 2-3 kerja dalam satu masa, kita boleh dengar juga dalam masa yang sama. Okey, so rugi. Okey, kalau kamu terlepas kelas tuition percuma ini. Baik, so sebelum kita tamatkan sesi secara langsung kelas kita petang ini, okey, kamu boleh tutup chat dekat situ. Okey, sebelum tu tekan juga butang subscribe dan aktifkan ikon loceng supaya kamu tak terlepas kelas kita pada minggu hadapan. Okey, dan share, setiap kali cikgu-cikgu share link kelas percuma, tuition percuma, kamu share lah dengan kawan-kawan yang lain. Ajak kawan-kawan untuk dapat ilmu sama-sama. Jangan kita je tahu. Kita sebab kita simpan kat kita je, so benda tu tak berkembang. So jangan lupa ya, dekat bawah tu ada dekat chat box ada link CJ. Seperti biasa link CJ ini akan tamat tempoh setengah jam selepas kelas live ini. Jadi kamu kena isi cepat-cepat, guna email e-didik saja. So sebarang kesilapan kita tak terimalah, jangan PM teacher lah ya. So kelas chemistry seterusnya adalah pada minggu hadapan, okey, hari Ahad pada pukul 3.30 petang juga. Okey, dan saya juga ingin menjemput para pelajar untuk ke portal kami di www.academy.youtuber untuk mendapatkan info terkini. Okey, untuk subjek-subjek yang lain juga. Okey, dan semua ini adalah usaha sama semua cikgu-cikgu di Akademi YouTuber, okey, untuk membantu para pelajar di saat kita melawan pandemik COVID-19 yang belum berakhir lagi kan. Okey, dan kita juga akan teruskan okey penyampaian ilmu melalui media sosial ni. Okey, so kami sangat mengharapkan sokongan daripada kamu untuk kami berikan yang terbaik kepada kamu semua. Okey, so sekali lagi Akademi YouTuber bermula percuma, selamanya percuma. Baik, terima kasih semua para penyokong Akademi YouTuber dan cikgu-cikgu di konti semua. Okey, sehingga itu sahaja, kita jumpa lagi minggu depan. Bye. Assalamualaikum. Selamat petang.
Tuisyen online percuma. Tuisyen online percuma. Layari www.academyyoutuber bagi mengikuti tuisyen online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma mestilah Akademi YouTuber.
Dibawakan kepada anda oleh Akademi YouTuber.